This tutorial introduces the concepts of acids and bases. We're going to learn about two different definitions of acids and bases. There are actually a few more, but these are the two that we're going to rely on, Arrhenius and Brønsted-Lowry. Arrhenius was the very first person to even try to identify an acid, and so his was very simplified and very to the point. He said if it was an acid, it would produce a hydrogen ion. So here HCl produces that hydrogen. These are all considered electrolytes because you have that plus and minus interaction. They tend to have a sour taste and they turn blue litmus red. They also tend to break down metals. To name these acids, there's a couple different rules. If it ends in "ide," like it comes right off the periodic table, so chloride, you're going to add hydro and ic. So hydrochloric acid. If you see more than one letter outside of that hydrogen, then you need to know that there's a polyatomic ion there and you need to know what it is. This particular one is 8. So instead of chlorate, it's chloric. Notice with these, we do not put the hydro in it. The hydro is only for the ones that come off the periodic table and cyanide. Chlorite is another one, so it becomes chlorus. So ite becomes us, 8 becomes ic. So here's a few common ones. Notice that there's only one element there outside of the hydrogen. So that becomes bromic, hydrobromic. Here we have NO2. NO2 is nitrite. Ite becomes us, so it becomes nitrous. Here we have CO3. CO3 is carbonate. 8 becomes ic, so it's carbonic acid. So let's practice some of these namings. We only have one element there outside of the hydrogen, and that's bromine. So that's going to be some kind of bromic. So bromus is out. So is it bromic or is it hydrobromic? It's hydrobromic because it's only one element. It's not a polyatomic ion. CO3 was carbonate. Carbonate, 8 becomes ic, so we have carbonic. And then we have bromite. It's more than one polyatomic ion, so we can get rid of the hydro. It's more than one element, so it's a polyatomic ion, so we can get rid of the hydro. So that gives us ic and us as an option. Is bromite, so it becomes bromus. Arrhenius bases produce OH minus in solutions. So these are the most basic kinds, so NaOH, KOH, CaOH2, so on and so forth. They all produce hydroxide. They tend to taste bitter or chalky, and they too are electrolytes because you have that positive and negative. They feel soapy and slippery, and they turn litmus paper blue. And you will name these just like you would name any other polyatomic ion compound. So the name of the metal and the name of the polyatomic. So sodium hydroxide, potassium hydroxide, barium hydroxide, just like you were doing before. So let's do some practice ones. This is nitrite, so it becomes nitrous. This is simply calcium hydroxide. There's no trick to naming those. This is sulfate, so that comes sulfuric. This is iodate, so it becomes iodic. And then once again, sodium hydroxide. Now Brønsted-Lowry actually ended up expanding this definition a little bit. And the real difference comes in with the bases. Instead of simply saying it always produces an OH, instead it says that it always absorbs a hydrogen. So here the H2O absorbs this hydrogen from the HCl. So no OH minus is actually produced, but it does absorb that hydrogen. So here we have a base. A base absorbs a hydrogen, so it goes from NH3 to NH4. while the water gives away that hydrogen. So these two get connected by looking at it, and these two get connected by looking at it. The biggest difference between Arrhenius and Bronsted-Lowry is right there. So, in each of the following, identify the Bronsted-Lowry acid and base in the reactions. So here we have HNO3. If we look on the right-hand side, here's NO3 again. It's missing a hydrogen. So that means this was the acid. And we are preluding to something here. H2O to H3O, this absorbed a hydrogen, so this would be the base. HF to F, that one gave up a hydrogen. H2O to H3O, that one absorbed a hydrogen, so that would be the base. These, what we're pointing out, are called conjugate acid-base pairs. Is when you look at the before and after, and you want to follow the hydrogen as well as the anion that's bonded to. So in each situation, a hydrogen is given off and a hydrogen is absorbed. In this situation, NH3 gains a hydrogen, so it's absorbing a hydrogen here. So this is considered the base. Whereas here, the H2O is considered the water because it's donating a hydrogen. So write the conjugate base. So that means what it is after you've taken off the hydrogen. You can only take off one hydrogen at a time. So the conjugate base would be Br minus here. Here we can only take off one of those hydrogens. So of H2S, it's just HS minus. Instead of H2CO3, it's just HCO3 minus. You can only take off one at a time. Let's do the reverse. Now we're adding a hydrogen to it. So NO2 minus becomes HNO2. NH3 becomes NH4 because we're adding a hydrogen. But we're adding an H plus, so that changes that to a plus sign. OH minus, we're adding a hydrogen, so we're actually making it H2O. So which of these are conjugate acid-base pairs and which of them aren't? So you're going to look to make sure that the polyatomic ion matches up, and those do. So those are good. We're going to take a second look at these. We'll take a second look at this one. This one, ClO and ClO4, that cannot possibly be right because the first one doesn't have oxygen. We're going to take a second look at this one. We're going to have a second look at this one. So far the only one we were able to cancel out was number 3. The next thing I want you to look at is whether or not it gave off one hydrogen or two. Here it only gave out one hydrogen, so this is a pair. This one gave out 2 hydrogens, so that's not good. This one gave out 1 hydrogen, so that's an acid-base pair. This one, 1 hydrogen went from 3 to 4, so that one's okay as well. Finally, identify the conjugate acid-base pairs in this reaction. So, this is exactly what we were doing before. HNO3, follow the NO3. You notice it gave up a hydrogen, so this is the acid, which means that this is the conjugate base. Then NH3 to NH4, that means this is the base because it absorbed a hydrogen, and this would be the conjugate acid. And that is your introduction to acids and bases.